Hey, Math 206 students, we are wrapping up section 12.4 with an application problem, taking indirect measurements using similar triangles. So this is really the most useful, the most useful ideas in this section, I believe. The fact that you can measure really tall things using similar triangles, generally using shadows that are taken at the same time of day. So the example in your book is the largest pyramid in the world. It's impossible to measure the altitude of that pyramid. So instead, to take a measurement of what's the height or the altitude of your pyramid, you take an object that you know the height of. At the same time of day, measure the shadow of the pyramid and compare that against the person's shadow. So these triangles create similar triangles. The top of your person or whatever your reference is, the base of your reference, and the length of the shadow. So those 3 points create a triangle. And here, the center of the base of the pyramid, the vertex of the pyramid, and the tip of the shadow. Those 3 points create a triangle. These two triangles are similar by angle, because you have a 90-degree reference angle here, because supposedly you're standing at a 90-degree angle to the ground. And the angle of elevation of the sun, since you're taking these measurements at the same time of day, this angle of elevation has to be the same. So by angle, these two triangles are similar, therefore their lengths are proportional. So if you know the lengths of the shadow and you know the height of your reference object, you can figure out the height of the pyramid. So let's do that with like a standard activity that you would do with grade schoolers. Once you know what similar triangles are, you can go ahead and measure really tall things. So you do at a specific time of day when the sun's out so that you can see the shadows. You measure the length of a shadow of a really tall object like a tree or something. So suppose that the tree shadow is 40 meters, and at the same time of day you take a meter stick or some other object and you hold it up vertically and you measure the shadow. So suppose that shadow length was 2.5 meters. Then what's the height of the tree? So let's call that x. So I know that x over 40, because these two triangles are similar by angle, again, I've got two 90-degree angles, and this angle here represents the elevation of the sun. So by angle, these two triangles are similar, so I can create the proportion x over 40 is equal to 1 over 2.5. And everything's in meters, so I don't have to worry about converting anything. All right, so let's go ahead and solve for x. I'll multiply both sides by 40. So I get x equals 40 over 2.5. 16. So how tall is the tree? The tree is approximately 16 meters tall.